All right, tonight the Enderman and I are going to talk to you about geometric explicit equations. Now, this is very similar to the arithmetic that we did the other day, but now we're going to apply it to geometric. So just as a reminder, our equation is geometric sequence of the nth term, which is the term we don't know. Then we have the first term in the geometric sequence times the common ratio to the n minus 1 power. Okay, so remember this is the common ratio, and that needs to be the number it's being, the terms are being multiplied by. This is the first term that you see, and then your n is the sequence term that we're trying to find. Okay, so this is similar to what we saw the other night. Geometric sequences have to be multiplying by a certain number each time. So clearly we can see that this is times 2. Oops. And make sure, as we talked about the other day, make sure that it happens each time. Don't just check these first two. Make sure it works for the entire thing. So for the explicit sequence, we're going to go g sub n equals my g1, which is negative 2. The common ratio here is multiplied by 2. And then we had the n minus 1 power. Okay. Now, this gets a little more complicated when we want to simplify this. So in order to simplify this, we need to know a little bit about exponents. So what we do is we have negative 2 here. That stays the same. But now I can take each one of these exponents and apply it to the base number. So kind of like distributing when we were doing that the algorithmic or arithmetic sequences, we can make this 2 to the n power excuse me, times 2 to the negative 1. Okay, so basically I'm distributing the 2 to each one of these, so I just separate them out here. Okay, so then we need to do a little side note about exponents. Okay, so we're going to do a quick little side note about exponents. So you know when you have 2 to the 1 power, that's 2. And when you have 2 to the 2 power, that means 2 minus 2, or 4. And then if you have 2 to the 3 power, that means 2 times 2 times 2, or 8, right? So then there's when you have things to the negative 1 power. And you can't really do exponents to the negative 1. So what that means is I need to make that negative 1 positive. And how I do that is I do the reciprocal. So right now, this is the whole number 2 to the negative 1. To make this positive, I just do the reciprocal. So the 1 goes on top. And now this becomes 2 to the positive 1. So basically we just flip this, and when you flip it, the exponent becomes positive. So just as an example, let's say I had 3 to the negative 4. So I want to make this positive. So I put that over 1, and I just flip it. So it comes 1 over 3 to the positive 4. Okay? And then if I want to simplify that more, I would know that that's 3 times 3 times 3 times 3, or 1 over 27 times 3, that's 1, carry the 2, I think that's 91. Oh, 81, sorry, 81. Okay, so a little side note, you can also use your calculator, but you do have to know how to do this. So if on my calculator, I put in 2, and then I want to raise it, which is this, to the negative 1 power. Okay, so that's how I put 2 to the negative 1, and hit enter, I get 0.5, or if I want it as a fraction, I can hit math, and fraction's already highlighted, and we hit enter. Or if I want to look at this example here, I can do 3 to the negative 4 power, and that would give me a long decimal, or I can put it in a fraction, which gave me the 1 over 81. So basically, to make negative exponents positive, you have to flip it. The reverse works too also. If I had 1 over 2 to the negative 4, and I want to make that positive, I would flip these and bring it to the top as 2 to the 4th. Okay, so that was a little side note. All right, so going back over here, so now we know that we have this negative 2, 2 to the n power, and now we know to make this positive, it becomes 1 over 2. So then I have like terms here. I have negative 2 and positive 1/2. Okay, so when we multiply those, negative 2 times 1/2, put that over 1, and we get negative 2 over 2, or negative 1. So now I can simplify this by saying we have negative 1 times 2 to the n power, or I could just say negative 2 to the n power, g sub n. Okay, so let's look at another example. I know that was a little tough with that negatives, but really we just flip it, and then we can simplify it. So let's look at this example here. Here, I can see that these are going up by, let's see, if I times that by 5, I get 15. If I times that by 5, I get 75. And if I times this by 5, I get the negative 325. So I know I'm just multiplying by 5. Okay, so we're going to go our g sub n. And then if we look up here, g sub 1, which is negative 3. My r is 5. And then I have the n to the minus 1. Okay, so now we're going to simplify. So we're going to go negative 3, and then we're going to go 5 to the n power times 5 to the 1 power, because we're going to distribute this each to the n and the 5. Okay, so then to simplify, this has an n. So we know that nothing else has 5 to the n power. It's no like term, so we're going to leave that, right? So then I have these like terms. I have a negative 3. This was supposed to be negative 1, sorry, and then 5 to the negative 1. Okay, so let's bring those over here. I have negative 3 times 5 to the negative 1. So that gives me negative 3 times, when we want to make this the reciprocal, right? We'll do 1 over 5 to the 1. That makes, when I bring it down below, it makes it positive. And then to simplify this, I'll have negative 3 times 1, which is negative 3. 1 times 5 to the 1, which is 5. So that simplifies down to negative 3 over 5. Okay? Or I can write that as, oops, hold on, I have a phone call. And usually in exponential equations, you have your number here first, and then 5 to the n power. And that was g sub n equals that. So that would be my final answer. So I know this is a little bit tough because of this negative 1, but just remember you put it down below. I'd like to go ahead and give this one a try. See if you can put an explicit formula, and then we'll go over it more tomorrow. Have a great night.